for the roots of this function, but we have to identify any restrictions. This is a radical unit from grade 11, essentially. Not hard to do, except we didn't really spend a lot of time doing restrictions in grade 11. Okay, so the restriction of this, we know that under the root sign can't be negative. So it's going to be an inequality statement. We know that x plus 5 has to be greater than or equal to 0, right? So that would mean x has to be greater than or equal to negative 5. This is my restriction. This way you can reject answers based on your restriction. It's kind of like that non-permissible value, except it's a bunch of values. So how do we solve a radical equation from grade 11? What do I do first? Isolate the radical. Then what? Square both sides. Right? I did that. But then there was something else I'm going to do in grade 11. What did I have to do? Was the thing you hated the most? You had to check, because you've spent all this time doing the math. Now you got to check it. Does it fit our restriction? Is 4 greater than negative 5? Yes. Yes, it is. So it fits that restriction, so I don't need to reject it based on the restriction. I have to check to make sure that it works in the equation. I would suggest that you put it back into the original. So root of 9 minus 3 equals 0. 3 minus 3 equals 0. That's a good answer. All right. So using a graph, we're going to determine the x-intercepts. Easy peasy, right? So, what do you want to do here? Do you want to do x-intercepts, or do you want to find intersection points? Intersection or intercepts? We would find intercepts if we do this. This would be okay, that's option A. Option B is if we want to find intersection, you need 2 equations. So we would have y equals a positive 3 and y equals x plus 5. So if you set it equal to 0, the solution to this will be your x-intercept. If you do it as 2 equations, your solution will be where these 2 lines cross. What would it be? Intercept. That's what I would do, but that's just me. All right. So if we were to look at that, what kind of transformations do we have on that? Shifts, no stretches, that's nice. So what are my transformations? What does the positive 5 tell me? Left 5. And what does the minus 3 tell me? Down 3. That's your chapter 1 stuff. and that's going to keep popping up over and over and over again. So do you guys remember your table values from your original, equation y equals x? Okay, starts at 0, 0, 1, 1, 4 and 2, 9 and 2, right? Pretty easy. That's our basic table. So now if we want to do the transformations to it, zero, zero, where does it move table? The x's are moving left 5, negative 5. And the y's are moving 3 down, negative 3. If I'm at 1 and I move 5 left, I'm going to be at negative 4. If I'm at 4 and I move 5 left, I'm going to be at negative 1. And if I'm at 9 and I move 5 left, I'm going to be at a positive 4. And so if I'm at 1 and I move down 3, I'm going to be at a negative 2. 2, I move down 3, I'm going to be at a negative 1. I'll be at 0 here. You see your x-intercept? 4 and 0. Notice it's the exact same thing we solved algebraically. Well, I've been asked to do it graphically, which seems but we'll do it because I said we had to. All right, so negative 5, negative 3, negative 4, negative 2, negative 1, and 4, and 0. So my solution to this would be my x-intercept, which occurs at 4 and 0. Okay, so it says describe the connection between roots and x-intercepts. And the same thing. What's another word? Zeros. Zeros in the function. Right? Because the function has a value of 0. All right. So we're solving algebraically. Step 1, isolate the radical. It's already isolated. That makes me feel better. Step 2, square both sides. Okay, a little piece of the math teacher died. If you said the answer over here is x squared plus 9. Don't do that. You have to expand it. I'm going to have x squared. No. So I've got x plus 5 equals x squared plus 6x plus 9. If I'm going to solve, what didn't I do? What didn't I do before I got started? Didn't do my restrictions. So let's do that quickly because we already did it. X plus 5 has to be greater than or equal to 0. So x has to be greater than or equal to negative 5. Okay, I'm good now. Feel better about it. So 0 equals x squared plus 5x plus 4. So if I solve this, I'm going to have x is equal to a negative 4 and x is equal to a negative 1. Do both of those answers satisfy the restriction? Yes. Perfect. What's my next step? I had a chat. So again, I'm going to put it into the original equation. That is a good answer. And now we're going to check the next one. Maybe. So this is going to be, sorry, -4 plus 5 equals -4 plus 3. So I'm going to have the square root of 1 equals -1. You guys are like, yes, that is a true statement. You always tell us this value. We got to think positive, negative. But we're dealing with, we talked about this in the radical unit, we're dealing with positive principal root. Right? So what's the square root of 1? We're dealing with positive principal roots. It would be this, and we would reject that answer. Okay, so now if we're going to do it graphically, if we were to find the x-intercepts, it would, if we were to do this graphically and find the x-intercepts, this is how I find the x-intercepts, set everything equal to 0. If I did that, that's a transformation I'm not comfortable with. I know that this is 5 to the left and this is 3 down, but what the heck is that? So this isn't going to work. So now you have to do it intersection method. So now we're going to graph one graph. That's this. So we're going for option B because A, this thing is stopping me from doing it the intersection way. And on the other side, I'm going to graph that. So I have to find the point of intersection. All right, so if I did this before, this would be -5 and 0. You guys remember the table? 0, 0, 1, 1, 4, 2, 9, 3. What does this transformation tell me I'm doing to my x's? 5 left. Am I doing anything to my y's? No. So if I was at 0, 0, I'm now going to be at -5, 0. I'm doing this all in my head. If you need to write down a table of values, I would suggest that you do that for your notes. You guys have to decide what works for you. For me, I don't need to do it. So if I was at +1, and now at -4, and +1. From +1, I went to 4. So now I'm at -1 and 2. And then I was at 9 and 3, so I'm going to be at 4 and 3. What do I need to do with this graph? I need to label the function. What else would I need with this graph? 2 points labeled? Yes, that is great. All right, now we're going to graph the next one. You have to label 2 points on every graph. If you didn't do a table of values, David, you're a big fan of table of values. So you don't need to label your points because you've got a table of values on your page. Okay, perfect. So for this one, nice linear function from grade 10. I'm going to cross at +3, and the slope is 1 over 1. So up 1 over 1, up 1 over 1. Well, that's not opposite. I'm going to go down 1 over 1. Oh my goodness. Oh my goodness. Now all of a sudden it's kind of useful. Because what's the whole point of this activity is to see where they intersect. So this point here is your solution. So I don't care so much about the y value. I'm caring about the x value here. So the point of intersection is at -1 and +2. I don't really care about that y. The x is really what I need. So what's the solution to this graph? The x is the really important part. So the x is equal to -1 is your solution. Do you see the benefits of doing it the intersection method versus the intercept method? Okay, maybe. All right, let's do this using technology. So looking at this one, would I solve it algebraically or intersect? I would do intersections because what? Yeah, I can input it on that thing, but I can find intercepts on this thing too. But why would I have to use intersections instead of intercepts? We started that ugly x if we put it on the other side, right? So if we isolated this, it would be 3 root 3x squared minus 5 minus x plus 4. Have we ever done a transformation of an x squared? Have we? We haven't. So I don't think I would use transformations for that. There's stuff going on there that you are not perfectly comfortable with yet. So I wouldn't do transformations on this one and graph the 2, this being my first equation, that being my second equation, and A the 2, perfect. All right, so let's put those in our graphing calculator. So this might be a question on the calculator portion of your provincial exam, where a graphing calculator is useful to have. Or, no, that's where it would be located. I don't even know if they do a full technology question. They might, but this might be something that would be there. So we're going to do a second function, square root. I have 3x squared minus 5. If you have an older calculator, you might have to put brackets. You might have to close the brackets. This one doesn't require me to. On this one, my second one is a mixed linear function, easy x plus 4. Let me graph that. Actually, not a terrible window. I think I might change my window just. And my one minimum. I don't think I need that. go make it 10. In my line maximum, I could probably get away with not 15. Yep. Invalid measures. So I don't use your So why do you anticipate these two arms talking? The blue is my first one. It shows me that my blue is my radical function. My red is obviously my linear. Right, so it was a parabola that has vertex below the x-axis, right? And my guess is if we zoomed in close here, it would actually touch the x-axis. It's just showing me that it's off it a little bit. And so it would have its arms above the x-axis. So that part doesn't exist. So both blue parts make up that radical function. If you only graphed one portion of it, you would be incorrect. You need both. Okay? So points of intersection, obviously, we're looking at the first one and the first one. Now, didn't I reject one? No, that was my last question. So we actually have two solutions for this. So the nice thing is looking at it, we know when we go to solve it algebraically, I'm looking for two potential solutions. So if on the points of intersection, I would like this column here to do the first one. I'd like you guys here to do the second one. Jerome, you do the first one. Carmen, you do the second one. Second function, calculate. Option 5, because we're doing points of intersection. I don't see my cursor blinking anywhere on there. Look at that. Okay. So. Okay, so I'm saying that's my first curve, that's my second curve, and I'd like you to guess. So what's the most important part of this? Is it the x or is it the y? The x. So my first x value was at negative 1.8. What's my second x value at? 5.81. Positive. Makes sense. So those are my two solutions. Okay. There's three things to write down. It's not very exciting. I circled some things. And I wrote that down. You know you can print these off as soon as I'm done the lesson online. So if your goal in this class is to just write down everything I've written down, it's not super useful. You've got to make your notes what makes sense to you. So the little side notes. Somebody said to me they didn't want my printed off notes because they wanted to make sure they got all the side notes that other people had done in the class. So it is important that you take the opportunity, because when you guys go to university, your prof is not going to slow down for you, and oftentimes they'll put up their notes ahead of time and expect you to print them off, and then they'll ramble, and you got to figure out what they're saying and how it applies to those notes. Scratch down what makes sense to you. So it's not about getting everything copied down, it's about making sure it makes sense to you. Luckily, already isolated. What should I do first? How about I do my restriction? Three x squared minus 5 has to be greater than or equal to 0. So I'm going to have 3x squared greater than or equal to positive 5. X squared greater than or equal to 5/3. We're going to take the root of those. So x has to be greater than or equal to plus or minus the square root of 5/3. You want to know what that is as a number? The root of it? So x has to be greater than or equal to plus or minus 1.29. Just so we have an idea of what we're dealing with. So square both sides. So I'm going to have 3x squared minus 5 equals x squared plus 8x plus 16. I'm going to bring everything to the left-hand side, so I'm going to have 2x squared minus 8x minus 21. There's nothing fabulous about that trinomial. How do I know that? We just graphed it on the other page. So what am I going to do with this wonderful piece of information? Factor it with your quadratic formula. Okay, go ahead. Do you remember your quadratic formula? X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. That's a negative b, by the way. Okay, last page, last question, and then you are done your radical unit. I don't know why I have so much space. You guys have that much space on yours too. Weird. Last space. An engineer designs a roller coaster involves a vertical drop section. And chooses the equation of this to model the velocity in feet per section of the car's ride after dropping it to speed in feet with an initial velocity of 8 theta, or v initial, sorry, in feet per second at the top of the drop, blah, blah, blah. The design specifically specifies that the speed of the car, the ride's car, must be 120 feet at the bottom of the vertical drop section. If the initial velocity of the coaster at the top is 10, and the acceleration due to gravity is 32 feet per second squared, what is the vertical drop distance that should be used to the nearest foot? Did you do it? Okay, so let's talk about what we need to know. So V is what? V represents your start velocity or end velocity. This is your after the drop velocity. If you don't know what all of the letters mean, you're not going to be able to do it. The initial is your starting velocity. For those of you who took physics, not a shocker. For those of you who haven't, anytime we have V0, we call it the initial, that's where you begin. Acceleration is a constant, it's gravity. 9.81 meters per second squared, but this is giving it to us in feet, so it did the conversion for us. Isn't that nice? That's what gravity is on Earth. That's a constant, that's a known. You're expected to know that in physics class. It will always be given in math questions. And D is the distance of the drop. So those super fun roller coasters, you hope your engineers are good and that they've done their math well and that they're excellent mathematicians because they've got to figure this out so you don't die or get stuck in the middle. Stuck in the middle is the preferred instead of flying off the end and dying. So what is, in all that junk, what's V? What's the end velocity? Has to be 120 feet per second. I'm sure there's a math tableau that you can't see either, but that's not this question's problem. What's the initial velocity? We know what acceleration is. That's given to us. And it's asking how long the drop should be in order to have a final velocity of 120. Rounding matters in a case like this. You don't want to be too far or too short, because you want to make sure you have enough velocity to keep going through the loops. So we're going to fill in what we know. We're going to fill in what we know. So 120 equals 10 squared plus 2 times 32 times d. Before I square both sides, I'm just going to clean up some junk under the root sign. Just makes me feel better about life. So what am I doing? What? You mean square both sides? Is that what you meant? I gotcha. 120 squared. So not a lot of tough math on this one. So I'm going to have 14,300 equals 64D divided by 64 divided by 64. D is equal to, is it 223 exactly? Does the question say anything about rounding in there? Nearest what? So what's my answer? So that's being able to use variables to solve for an unknown in a particular situation. I can make to graph it. Oh, why? I might try to solve things algebraic.